Now let us discuss about the schmitt trigger. Okay, so the next experiment is your schmitt trigger circuit. Now you can just see the connections. Now I have inserted my operational amplifier, 3 10 kilo ohms resistor. So 3 10 kilo ohms resistor, and your connections I will just teach you in the Tinkercad now. So now you can see pin number 2, I have connected a resistor and given an input to the input from the function generator is given to pin number, this particular resistor where it is connected to pin number 2, and from 3 I have grounded one resistor, and from 3 again I have connected my resistor to pin number 6. Okay, you can just see one more resistor you have. This is connected to pin number 6. As usual, we have connected your plus 12 and minus 12 supply for the IC, and common is been grounded. Same place at pin number 6 also we are taking we have connected your CRO probe. So now you can see your function generator. This is your function generator where I have provided 1 kilohertz frequency and a signal of sinusoidal pulse I have provided. So here is the adjustment where you can make your frequency adjustment, and here is the amplitude adjustment which you can make it for your sinusoidal pulse, and this is the place where from you have to take your input to the circuit from the function generator. Now this is the sine wave which I have produced. Now if you just put it into, this is going to be your output. Now this is the input sinusoidal signal which we have taken from the circuit which we have given it. Okay, so now let me just move on to the circuit. You need not change anything. Once you have applied your 1 kilohertz frequency with an amplitude of the sinusoidal pulse, you can just go on for directly looking into the waveform which will be automatically generated into the CRO. That is why we call your schmitt trigger as the regenerative comparator. That is why we call your circuit as the regenerative comparator. Now you can just see your waveform which we are going to take it. Look into the waveform. Initially, which I have shown you in the beginning, that was your input. Sinusoidal waveform is the input, and square pulse which you can visualize in the dual mode. So now see, this is your sinusoidal waveform, and this is the output which we have received during the conduction of the experiment. Okay, so as soon as you give your frequency and you apply an amplitude, you can just visualize your output. Now you can just see it is not a normal comparison. Here you have upper threshold and the lower threshold value. So the intersection point of the square pulse, you can see one upper point is intersecting in the upper half of the cycle, and the lower point is intersecting in the lower half of the cycle. So here you have two threshold values. Whenever your input voltage crosses the two different voltage levels, then all your output will be varying from plus V saturated to the minus V saturated value. So your output waveform, your square pulse is the output waveform, and square pulse is the output waveform. Okay, square pulse is the output waveform and sinusoidal pulse is here. So now see, now measure your upper threshold and the lower threshold value from the midpoint. Now you can just see midpoint is this, and from there your upper threshold is going to be only one box and the lower threshold is going to be one box. But your sinusoidal waveform, the total amplitude is 1, 2, 3 and 3.8. So at the maximum 3.8 is the amplitude, and you have to multiply your voltage division. You can just make a note, voltage division of your this thing. So now this first channel is for your input and second channel is for your output. Voltage division is, you have 2.8 into 50 milliseconds, and here this is going to be 10. Okay, you can just make it into this thing. So now here this is going to be 1. Your multiplication factor for the time division is 1. Here output waveform doesn't need a time division. You have to make your line as the intersection point. Intersection point, you have to extend the line and draw your pulse. Only your plus V saturated and minus V saturated, as we have discussed in the theory, we are able to witness all the outputs in your practical session also. Now this is all about your schmitt trigger circuit. Now the connections can also be made it in your Tinkercad software for the virtual lab session. That also will be discussed in detail in your laboratory session. Thank you.